Welcome back, everyone. Welcome back to my math channel online today. In this video today, I would like to show you how to solve the word problems involving the polynomial function. So let me read the word problem to you. So I'm going to do number 2 first, right? I'm going to do this number first. The height of one of the face of a triangular prism is 2 less than the length of the base of the prism face. And the height of the prism is 2 more than twice the length of the base of the prism face. If the volume of the triangular prism is 90 units cubed, what is the height of the prism? So let me show you the diagram here. So we have a triangular prism, and it says the height of one of the face of a triangular prism. So let's say the bottom here is one of the face of triangular prism. So the height of this, I call it height 1. That's the height 1 with the solid light form of the triangular prism face. So this is the bottom face, right? But it could be the same like on the top, whatever you want to. So I just mark here the solid triangle height 1. So they're talking about the height of one of the face of triangular prism, which is height 1 here, right? If you see height 1 here, is 2 less than the length of the base. So we have the length of the base from here to here, and we know that height 1 is 2 less than the length of the base of the prism face. And the height of the prism, so the dotted line all the way from here to here is the height of the prism. So I call this is height 2. So the dotted line from the top to the bottom of the prism, this is the height 2. And they say that the height of the prism, so the height of the prism is the height 2. Height 2 is 2 more than twice the length of the base. So this unit have 2 more units more than twice of the length of the base here. If the volume of the triangular prism is 90 units, what is the height of the prism? So the question for what is the height of the prism, which is height 2. The question asks for height 2. So how do we solve this problem? In order to solve the problem, we have to establish a function. And based on the data given, we can establish our function based on that. So I'm going to say let L, right, be the length of the base. The length. Now, this length, we don't know, right? We don't know how much it is. So I just say let L, or you can say let X as well, doesn't matter, right? X of L, I represent L by a letter of the length of the base. Be the length of the base, and of course triangular base, right? Triangular base. The height of one of the face of triangular prism is 2 less than. So therefore, based on this statement, the height is 2 less than the length of the base. So now we can say, therefore, height 1 equal L minus 2. Right? So this height 1 of the triangle of the base from here to here, the solid line here, is 2 less than L, because that's what they say here. 2 units less than the length of the base of the prism face. And the height of the prism, which is height 2, right? The height of prism, which is the dotted line here, height 2 here, is 2 more than twice the length. So the height 2 will be equal twice the length, right? Which is the length here, L here, multiply with 2 because they said twice the length. So we multiply with 2, so we have 2L, and the height of prism is 2 more than. So after we multiply the length here, so height 2 will be equal to 2 length twice, right? Twice the length is 2 length, adding with 2 more units. So that's the height 2. So based on this word problem, we establish our variables here. So our variable is L instead of X. I can put X as well, but I try to use a letter like a cooperate with the related to the problem, right? So I use L instead. So let L be the length of the base, which is the length of the base here. And the height 1 here is equal the length of the base minus 2 units. So this unit equal this unit minus 2. Height 2, which is the height of the prism on the top to here, equal to length twice the length, adding with 2 more units. So at this point, I already established the variable for our problem. So now the question say, if the volume of the triangular prism, so the whole volume of the shape, right, is 90 cubic units, what is the height of the prism? So in order to establish the function, we will say volume, right? Volume of X or L. In here, we use the variable L. So I say volume of L will be equal. We have to relate it back to the volume formula of triangular prism, right? The volume formula of triangular prism say, if this is a triangular prism, then we will use the area of the base, which is the area of this face, right? Of the base face here, the bottom here, the area of the bottom here, or the area of the top, doesn't matter. They look exactly the same, right? So we can use the area of triangle. And you see that because the shape, in the shape of triangular prism, so the face, the base face of it is a triangle, right? And the height here, you can lie it down, it become a length of prism, or you can stand it up like this, it's still the same, right? So the triangular prism have a face of triangle. So any volume will be equal the area of the base, and it turned out our base here is a triangle, right? So area of triangle time with the height of the prism. So because volume is a 3 dimensions, right? So we have an area of 2 dimensions multiplied with the height, it becomes 3 dimensions. So here we will use the area of triangle. So V of L here will be equal, the formula for the area of triangle is base, right, times height divided by 2. And our base here is L. So will be equal L time width, height, and height 1, right, divided by 2. That is the formula of the triangular. Now this will time width, the height of prism, which is height 2. So we're done with this, but now we have to substitute into VL. So we have H1, H2, L. So we have 3 variables. It's not good. So we try to put everything in terms of 1 variable instead of 3 variables, right? Because we have L here, we have H1 here, and we have H2 here. They are unknown letter. So in order to solve any problem, you have to solve 1 equation with 1 unknown only. You cannot put in 2 or 3 unknown, and then how can you solve it, right? So we have to put everything in terms of L here. And we have it, right? We have H1 equal this, L minus 2. We have H2 equal this. So all what we do is we substitute it in, right? So we have VL equal L is just L times with H1, and I'm going to put in the bracket, times H1. H1 is L minus 2. And this will divide it by 2. And time with H2 is 2L minus plus 2, 2L plus 2. So that's the volume. And we know the volume. They said that if the volume of triangular prism is 90 units, so it equals 90. So that's the equation we established based on this word problem. So at this point, we can multiply them, simplify the expression, and get into the function, and we can use synthetic division to try to factor it out and solve for L, right? So let me show you how we do that. So in order to do that, I need the room here. So I'm going to have to erase this. Now we have all from information here already. So we don't miss this anymore. Erase this. Again, if you register to my course, you will not missing anything of this, right? It will show you on a sample solution, and you can use that as working out for other word problems. Okay, so I'm going to copy this formula up here. VL equal L times L minus 2 divided by 2 times with 2L plus 2. Now, at this point, I'm going to bring the 2, I'm going to divide out the 2L here with this 2 down here and the 2 here down here. So if I divide it, I cancel this with that, and I cancel this with this, right? I will get volume equal L times L minus 2 times with 1L instead of 2L because I divide down here, right? They are in bracket, I am allowed to divide, right? So I cancel 2 here with 2 here. So 2L become 1L because you divide by 2. 2 divided by 2 equal 1. So this is the volume function. And this equal 90. Now I'm going to multiply through, right? So I will have VL equal L square, L times L, L square, minus L times 2 is 2L, times with L plus 1 again. So now I'm going to have to multiply one more time. L times L2 is L3. L times 2L is minus 2L square. 1 times L square is plus L square. 1 times minus 2L is minus 2L and equal 90. So now I'm going to add the algebra like term together, this and that. So I end up with L to the power 3 minus 2L square plus 1L square. So equal minus 1L square minus 2L. I can move this over. Minus 90 equal 0. So now is a method of solving this using the synthetic division. So how do I use this to find out the divisor of this? So first we will split this constant term into the number that you can factor it, right? So I'm going to split this become 9 times 10. That is the first factor. We also can split this the 3 times 3. And this is 5 times 2. Now, if I substitute any of this factor into the equation and they get a 0, then that is the factor of this function, right? Of this function volume. Now, if I choose 2, let's say if I choose 2 first, right? Then what do I have? 2 to the power 3 is 8, minus 2 to the power 2 is 4, minus 2 times 2 is another 4, minus 90. All of this not going to give me a 0. So I know that I have to change it, right? So if I choose, let's say if I choose 5, so I will say V5 will be equal what? 5 to the power 3 minus 5 to the power 2 minus 2 times 5 minus 90. So that will give me 125 minus 25 minus 10 minus 90. So yes, it's give me a 0, right? Because this is 125. 90 and 10 is total negative, is 100. 100 add another negative 25 is 125. So this is minus 125. You have a positive 125 minus 125 equals 0. So now I know this L5 is work. So I'm going to use a syntactic division, right? So this function have 1 for L3, minus 1 for L2, minus 2 for L, and minus 90. So I'm going to use syntactic division to make it quick. And our factor is 5, I put in here. So 1, I bring it down. 1 times 5 is 5 minus 1. Adding with 5 is positive 4. 4 times 5 is 20. So I'm going to put positive 20. 2 minus 20 is plus 18. 18 times 5. Okay, let me see. So we have, 5. So we have 1 for this, minus 1 for this, minus 2 for this, minus 90. Yeah, so 1 times 5 is 5. That's 4. 4 times 5, 20. 18 times 5. So what 18 times 5? 90. So I got 90, and this is adding, so this becomes 0. So yes, so the remainder is 0. So what do we have? This one here. This one here will become x squared plus 4x plus 18. Now at this point, I can use a quadratic function to factor it, right? Equal it down to the degree 2. So now quadratic function, this can be changed as 6 times 3. That doesn't work. So what about 9 times 2? It doesn't work either. 6 times 3, 9 times 2. Yeah, so we have to, at this point, we have to use the quadratic function to solve this problem. But let's see, we already know L here, right? One of the factor L equal 5, right? One of the root of this equation is L equal 5. So let's say if we stop right here, okay? If we stop right here, we know that if our L equal, so we solve for it, and one of the root equal 5. Okay, so what happened if L equal 5, then H1 will be equal what? H1 will be equal L minus 2, right? L minus 2. So 5 minus 2, which is 3. And H2 will be equal 5 times 2 is 10. 10 plus 2 is 12. So let's multiply all of this number together to see if we get the volume, right? So volume will be equal, our volume equal 90, right? So if we multiply this and we get 90, then that's correct. So our volume will be equal area of the bay, which is 5 times with the height, which is 3, divided by 2. And then time with the height 2 is 12, right? 12. So 12 divided by 2 is 4. 6. So yes, 6 times 5 is 30. 30 times 3 equal 90. So yes, we do get the volume equal 90. So L equal 5 is the correct answer, right? And that is how we try to find the dimension of this volume. So we solve the problem right here. We don't even have to continue to factor this out, right? Unless we have to. But in this case, you establish the function of volume, and then you find the dimension, and you just plug in the number and check if the volume is 90, and I check it. 5 is the length of the base, time with the height 1 is 3, divided by 2, time with the height 2 is 12, right? So we got 90, yes. So the problem was solved. So now I'm going to show you how we're going to do the next problem. Now the method is when we read the word problem, we have to know which one is establishing a known variable, and we establish, right? So then we don't have any problem when we solve the word problem. So let me erase this, and I'm going to show you how to do this. The next question. Okay. So I'm going to read the next question to you. John has a utility trailer that is 10 feet long, 6 feet wide, 4 feet tall. So let's put in the summary note. So John have a utility trailer, and I think I have a diagram here, right? That is 10 feet long. So from here to here is 10 feet long, 6 feet wide. From here to here is 6 feet, and 4 feet tall. So from here to here, from top to the bottom is 4 feet tall. He wants to add a certain amount to the width, take the same amount of the height, and add twice as much to the length as he added to the width. Write a polynomial that would represent the volume of his new trailer. How much would he add to the length and width and remove from the height if a new volume is 3.75 cubic feet more than the old trailer? Okay, so first we know the length of the trailer is 10 feet. The width of the width of the trailer is 6 feet, and the height of the trailer is 4 feet tall. So we can calculate the own volume, right? The own volume of trailer is just the rectangular prism, which is length times width times height. Length times width times height, which is equal 10 times 6 times 4, which is equal 240 feet. Now the new volume is 3.75 cubic feet more than the old trailer. So we're going to add 240 feet here. This is the old trailer. adding with 3.75 feet. So this will become, and this is cubic feet, right? So this becomes 243.75 cubic feet. That's the volume of new volume. So now we know that. Now write a polynomial that would represent the volume of his new trailer. Okay, so let's say John have a utility trailer that's 10 feet long. He wants to add a certain amount to the width. So we don't know how much is a certain amount, right? So let's use the word X this time. Let X be the amount, right? The amount. He wants to add a certain amount, right? The amount to the width and take the same amount of the height. So let X be the amount added to the width, So therefore, we will have a width equal the new width, right? The new width will be equal 6. You want to add a certain amount to the width, so will be equal 6 at X, right? We can't, because we don't know how much he want to add in that. So we call that the X unknown number. And now we add this unknown number to the width, and the problem say he wants to add a certain amount to the width. So add to the width, right? The width equals 6, 6 add to X. Take the same amount, right, of the height. So he will subtract the height from, he will subtract the X from the height. And the height here is 4, right? So 4 minus X, that's what he wants. Take the same amount of the height, right? 4 minus X. And add twice as much to the length as he added to the width. So for the length, he will add twice. So the length is 10. Now he will add twice as much to the length as he add to the width. So 10 add 2X. So now we have new variable in here, right? And all of this new variable will create a new volume, right? Volume new, I'm going to say like that, will be equal 6 SX multiply with 10 at 2X and multiply with 4 minus X. And we can say this is volume of X, right? Of X. So that's the function. This is the volume function, the same like polynomial function. So the question says write a polynomial function. And this is what you write, right? Will be equal the new volume, right? The new volume is 243.75. So to solve this polynomial, all what you have to do is X plus 6 times with 2X plus 10 times with X minus 4. No, 4 minus X. 4 minus X. And equal 243.75. So all what you have to do is try to figure out what is the factor to make this expression become 0. You can tie them together, right? Just like we did on the second problem. And we get to the x to the power 3, blah, 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 right? Let's x squared, whatever. We can tie them. Now, let me tell you the hint that by doing that, that is the formula so that we can solve any polynomial, use the syntactic division like we just did in the first question. But depend on the question. This question have a decimal number. And so the factor of it is a little bit tricky, right? So if we try to figure out on the factor of this number, it's very tricky, right? So my hint to you would think about all of this x here, add to this one, 2 times x here, add to this 10, and minus x here. All of this is create a power 3, right? When you tie this, and let's say if you subtract 240, which is the own feet, right? The own volume, then you left with 3.75. So 3.75 is a very small number. It's easy to factor, right? So let's say number ending with 5, I will divide by 5. So I'm going to divide this by 3.75. Let's say if I divide it by 1.5, I will get 2.5 times with 1.5. So now by narrowing down like this, I can try to substitute any of this small number into this equation and see if the left side equals the right side or not, right? If I substitute 2.5 and it doesn't work out, then I can substitute 1.5, right? And try this first before you try to get in the huge number. So leave them in the bracket like this, it's easier, right? As long as you put the x equal 1.5 in here and it work out, or x equal 2.5 in here and work out, then the left side equal the right side, then the problem will be solved, right? So let's do that first so that it's easier, okay? So I'm going to try, right? So I'm going to say try, and I'm going to substitute the small number first, try 1.5, okay? So I'm going to use v of 1.5 will be equal 1.5 plus 6 times with 2 times 1.5 is 3, right? 2 times 1.5 is 3 twice, adding with 10 times with 4 minus 1.5, right? So I'm going to calculate to see if I get it done. So this will give me 7.5 times with 13 times with 4 minus 1.5. 4 minus 1.5 equal 2.5. So let's tie them together and see what happens. So I'm use 2.5 times with 13 times with 7.5. I get 243.75. Exactly number 243.75. So yeah, it's worked out, right? Left side equal right side. So now we know the x here equal 1.5. So let's calculate what is the width of the new trailer. The width will be equal 7.5 and the length will be equal 10 at 3 is 13, and the height will be equal 2.5. And this is feet, right? So feet unit. So that is on the 3 dimension you saw using the just establish the polynomial function, and we'll be able to solve this problem. So I hope you enjoy this video. And if you register to my course, you will have similar problem like this to practice, and you will have the sample solution here. And sometimes I tie it in the Microsoft PowerPoint presentation beautifully. And so you can have all of this material, and with understanding like this, you will try to read the word problem and try to establish the similar ideas and solve the problem. So thank you for watching my video today, and bye for now.